Alright, thanks for tuning into section 6.1 part 2. We're going to go and look at those reciprocal, quotient, and Pythagorean identities once again. But before we do that, I want to do a quick review of how to actually simplify fractions, because a lot of these questions here involve fractions. I know you guys hate those F words. You guys hate saying those F words, like factoring and fractions. Yeah, those F words. So in any case, let's see if we can eliminate some of your fears of the fractions by doing example number 0. Okay, let's simplify the following. When we have multiplication, I hope you remember a by itself can be written as a over 1. And before you multiply everything out like a, b, c, and c, a, b, it's nice if you can actually just cancel, or not, sorry, I shouldn't say cancel, divide out things. So if you see something the same on the top and the bottom, when it's in multiplication format, you can divide things out. So, for example, the a and the a divide out to 1 and a 1. Same thing with the b and the b, and same thing with the c and the c. So, oh yeah, this just equals to 1 times 1 times 1 over 1 times 1 times 1, which is just 1. Okay. Now, if you didn't do this dividing out stuff first, you could have just went a, b, c, c, a, b, right? Multiply all the numerators together, multiply all the denominators together, but that still equals to 1. Same thing. Okay. Aha, division. Remember, division is the same thing as multiplication by the reciprocal function. So we take the reciprocal of the second fraction, that becomes d over c. Since there's nothing we can actually divide out, we just have to straight multiply now, a times d over b times c. Okay. Part C, notice that the denominators are different. That's like me saying 1/3 plus 1/4. And when they're different, we must find the lowest common denominator. And in this case, the denominator would be b times c. So I'm going to ask you to rewrite b times c as your new denominator. For the fraction on the left, notice I'm missing the factor of c, so I'm multiplying both the top and the bottom by c. For the second fraction, I'm missing a b on the bottom, so I'll get bb or b squared. Okay, once the denominators are the same, then we can combine the numerators together. So AC plus B squared equals, or sorry, all over BC. And that's what it simplifies to. Okay, let's do another one. Notice this is A plus 1 as the denominator and A minus 1. Your lowest common denominator is not A, okay? A plus 1 and A minus 1, those two things are totally different, just like the 3 and the 4 from above, okay? That's one item. Here's another item. They're totally different. So therefore, the common denominator must just be those two things multiplied together. Just like before. And I think on the numerator of the first fraction, I'm missing the a minus 1. And for the second fraction, I'm missing the a plus 1. Notice that minus sign there applies to the entire function, okay? So be careful about that. Since the denominators are the same now, I'm just going to combine everything together. So a minus 1. Here I go distribute negative 2a, and negative 2 times 1, that's minus 2. And that simplifies to just negative a minus 3 all over a plus 1 times a minus 1. Stop right there. Okay, E. Whoa, complex fractions. Yuck. Well, trick to these ones is to do the numerator separately from the denominator first. Okay. Once again, try to combine everything into one fraction. So notice A is just A over 1. So the common denominator between 1 and B must be just B. So therefore, I think the first term I'm missing a B, so it's AB. And then the second term will already have the b there, so I'll just leave it. Nothing's missing, just the 1. Okay. Similarly, for the bottom, this is b over 1, so I believe the common denominator between 1 and a is just a. So then we have b, and we're missing the a, so ba, and then we have plus 1. So now we have this interesting scenario where we have a fraction, over a fraction. So this over, this bar means divide. So a lot of times I'll rewrite this as AB plus 1 over B divided by BA plus 1 over A. And when you see this, people seem to be like, oh yeah, I know how to handle this now. That's just like part B from above, right? Part B here, the division is the same thing as the multiplication by the reciprocal. So I'm just going to ask us to do that then, okay? Times A, and then BA, by the way, can be written as AB, okay? Doesn't make a difference, the order. I wrote it as AB. Hopefully you know why I did that now, because look, this whole AP plus 1 and this whole AB plus 1 seem to be the same. I'll divide them out, and you're just left with 1 times A over B times 1. There we go. Okay? That was a quick review of fractions. Now, why is that important? Because now I'm going to show you questions where you're going to use fractions and you're going to have to do some sort of simplification. But before we do that, a quick review from part 1. These are all the things you learned from part 1. Okay? The reciprocal and quotient identities, well, we kind of learned those before, but I'm going to formalize them for you now. But the Pythagorean identities were something that was new. Sine squared theta plus cosine squared theta equals 1. And there's other ones, tan squared theta plus 1 equals secant squared theta. And of course, 1 plus cotangent squared theta equals cosecant squared theta. You are going to use all of these, okay? And that's why I said you better have these kind of memorized and have them handy, all right? And that's why I wrote them down here again for your convenience. Let's take a look now. Page 2. Here are some examples. I want you to simplify the trig expressions and then also determine the non-permissible values, okay? Let's do the simplification first, and then we'll take a look at the NPVs, because we're going to see where our denominators are going to be. Okay? All right. For 1, oh man, sine, tan, cos, whoa, too much stuff. See if you can change them and eliminate some of the trig ratios. I like to keep sine and cosine. Sine, cosine, tangent, and all the other ones, oh, that's too much stuff. Let's just keep it simple. Let's keep it as sine and cosine. So therefore, the tangent, I believe, we should change into sine theta over cos theta. Okay? Bottom, no change. Now you might be a little bit scared now. Your numerator here is kind of freaky. You've got a fraction involved. So let's see if we can simplify that. Let's find the common denominator for the top, the numerator. This is like over 1, so that's just cosine theta, I believe. And that would be then sine theta times cos theta. And then the other fraction is just sine theta, so we'll keep it as is. We're still dividing this by cosine theta plus 1. Okay? But I noticed something interesting with the numerator now of the top. You see sine theta, cos theta, sine theta. How about factoring what's common, which is a sine theta? So we're now having a cosine theta plus 1 in the bracket. Hope you can see that. The denominators are still the same. Now, this might be a little bit more helpful because now I'm thinking, hey, that big bar here is division. So I'm going to take that fraction. Okay, so sine theta bracket cos theta plus 1 all over cos theta. This is dividing by cos theta plus 1. Now, dividing is the same thing as multiplying, right? And so, running out of space here, but sine theta cos theta plus 1 over cos theta times 1 over cos theta plus 1. See anything that can divide out nicely? I hope you can. And we're left with sine over cos, which is just equal to tangent. There you have it. Tangent. Now, we have to do all these NPVs. So where do the NPVs come from again? Yes, denominators. Fractions. Denominators. So where do we see them? I see an NPV possibility right here. And I see another one right here. So 2 parts where there could be non-permissible values. First one is where cosine theta, of course, can't be 0. We've done this before many times. Theta can't be 0 at, I think, pi over 2, 3 pi over 2, and so on and so forth. So I'll just write the general solution. And I think we've done this before, so I'm not really spending too much time. Okay. The other one, of course, is where cosine theta plus 1 cannot be equal to 0, so cosine theta can't be equal to -1, and that happens at pi and everything else after that, so pi plus the cycle, of course, is 2 pi n. Okay? There we go. Done! Okay. B! Well, I guess in this case, I'll do the NPV first because there's cotangent theta. So NPV cotangent theta can't be equal to 0, which means, of course, I guess that means tangent theta can't be equal to 1 over 0, which is undefined. Where is tangent theta undefined? Oh yeah, at like pi over 2, 3 pi over 2, and so on and so forth. Really just pi over 2 plus pi n. N is an integer. Okay. Anywhere else you see? Probably nowhere else, hey? Okay. So, let's go and simplify. Once again, sine, cosine, cotangent, yuck, 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 yuck. Let's try to change everything in just sines and cosines. Sine theta plus cos theta. And cotangent is the same thing as 1 over tan, which is, that's cosine theta over sine theta. Yes, I remember that. Same thing down here, then this must be cosine theta over sine theta. Well, let's see if we can simplify the numerator first. I think we got the same kind of scenario as what we had in part A. Sine theta plus, oh, look at this. This is now cosine theta over 1. So cosine theta times cosine theta is cosine squared theta over sine theta. And our bottom still here, cosine theta over sine theta. Let's see if we can simplify the numerator. Let's make them all over the same denominator, which is sine theta, which means now my term here of sine theta is missing another sine theta, which becomes sine squared theta. Cosine squared theta. Ooh, I like what I see, because I think that can simplify into something beautiful. What's sine squared theta plus cosine squared theta? Yes, Pythagorean's identity becomes 1. So this we have now is 1 over sine theta all over cosine theta over sine theta. And I think this looks good because now we can divide. By the way, I'm showing you lots of steps. If you can skip a few, you're more than welcome to do so. That's now 1 over sine theta times, or sorry, I should say divide first. Don't want to skip too many steps. Okay. Divide that by then cosine theta over sine theta. That seems to be the same thing as 1 over sine theta. Division is the same thing as multiplication. Oh, yes. And then lo and behold, I see something dividing out nicely. We're left with 1 over cos theta. And that's the same thing as, you guessed it, secant theta. Ta-da! Wow, that became just a simple trig ratio of secant theta. Okay, here's another one for you. Okay, 1 plus cotangent theta, 1 plus tangent theta. Well, I'm going to do the NPVs first, okay? NPVs, of course, here. Oh, actually, you know what? I won't do that yet. Let's do the simplification first. Yeah, let's do that first, okay? Once again, cotangent, tangent. One of the tricks here is just to turn everything into sine and cosine. So if you want to do that here, you're more than welcome to. Cotangent, of course, is just cosine theta over sine theta. Okay? And tangent's just 1 plus sine theta over cosine theta. So in this example, I'm going to ask us all to try and rewrite them, at least the numerator, with sine theta as my denominator. And then for the bottom, I think let's use cosine theta. Remember, 1 is just 1 over 1. So the numerator I have here is sine theta plus cosine theta. And on the bottom I have now cosine theta plus sine theta. Well, you might be thinking to yourself, that's kind of nice. I think so too, because now this ugly fraction can be written as the numerator divided by the denominator. So sine theta plus cosine theta all over sine theta divided by cos theta plus sine theta all over cos theta. We know that dividing is the same thing as multiplying by the reciprocal. So we'll write this as times cos theta all over cos theta plus sine theta. Anything here that divides out nicely? I think there is. This whole thing of sine theta plus cos theta. Cos theta plus sine theta. It doesn't matter the order. When you're adding, it's the same, right? 3 plus 4, 4 plus 3. So we're just left with cosine theta over sine theta, and lo and behold, that's just cotangent theta. Ding, ding, ding. There you go. Your NPVs, you might be wondering? Sure, let's do those over here. Okay. We've got 1 plus tangent theta, the obvious denominator, right? Yeah, the obvious part. That, of course, can't be 0, so therefore tangent theta can't be equal to -1. That would be what? Negative pi over 4. Oh, yeah, I think that's negative pi over 4. Excuse me. Negative pi over 4. And of course, we can just add to that pi n. Okay? By the way, if you don't like negative pi over 4, remember, you could always just draw this out. Negatives are like here. Don't like that. You can always go this way. 2 pi minus the reference angle of pi over 4. So if you like angles that are positive, you can replace that with 7 pi over 4. It doesn't make a difference. Okay? However, that's not the only non-permissible values here, because notice when I actually did the simplification and changing cotangent into cosine and sine, there's another one. Oh, here's one more. So there's actually a few more spaces here, or places here, that you can actually have non-permissible values. Sine theta can't be 0, therefore theta can't be equal to 0, pi, 2 pi, etc. So that's just the same thing as pi n, where n is an integer. And then cosine, yes, cosine theta can't be 0. And when we do that one, theta, I believe, can't be pi over 2, 3 pi over 2, etc. So that's really pi over 2 plus pi n. So restrictions, kind of nasty. Okay. Let's move to page 3. Some few more. I'm going to ask you to show algebraically that these trig equations are identities. Once again, identities means that the left side equals the right-hand side. And this time I'm not going to ask you to do the restrictions because, well, I just don't want you to. You could if you wanted to for fun. Okay? Alright. Let's take a look. Always, I think, start from the more ugly side and try to get to the easier side. In this case, I think the left-hand side is ugly, so I'll suggest let's go from the left-hand side to the right-hand side. Okay? We'll expand. So 1 times 1 is 1. 1 times tangent squared just becomes tangent squared theta. Negative cosine squared theta, that's this. And then negative cosine squared theta times tangent theta, that's just, I believe, well, negative cosine squared theta times tangent squared theta. Your goal now is to try to simplify here, okay? I'm thinking, well, sine, cosine, tangent, even though there's tangent on the right-hand side, I'm thinking it might be nice just to change everything into sine and cosine. I'll just do that anyway. So sine squared theta over cosine squared theta minus cosine squared theta minus cosine squared theta. And tangent, once again, is sine squared theta over cosine squared theta. Okay? See anything else you can simplify? Yeah, here's the two cosine squared thetas. They kind of cancel each other or divide out. So now I see 1 plus sine squared theta over cosine squared theta minus cosine squared theta minus sine squared theta. And anything else? Well, you might be thinking, hey, this kind of looks like sine squared theta plus cosine squared theta if you were to factor out a negative. And that's what I think we should actually do now. And I'll rearrange the, I won't need to rearrange the order. I think you guys are smart enough to know that sine squared theta plus cosine squared theta is the same thing as cosine squared theta plus sine squared theta. That's just equal to 1, so yeah, 1 plus sine squared theta over cosine squared theta minus 1, and that just simplifies to, oh yeah, sine squared theta over cosine squared theta, and that's tangent squared theta. Done. Okay, I'll let you try the next one. Same kind of principles. If you can start from the ugly side and make it equal to the nice looking side, life is good. So I'm thinking for part B, if I were you, and I'm not, but if I were you, I start on the left hand side. Okay? Notice we've got fractions, the denominators are different, so my advice to you is probably make them into fractions with the same denominator. And what would that be, you might be thinking? How about 1 plus cosine theta? And I'm going to ask you to multiply that by 1 minus cosine theta. Okay? So go ahead and do that. Use your ideas of adding fractions to see what's missing on top. Okay. And then let's see what things simplify to. Alright. Well, it looks like the numerator just simply becomes 1 minus cos theta plus 1 plus cos theta. Bottom here is just 1 plus cosine theta times 1 minus cosine theta. Probably going to ask you to expand out the bottom because I see the top is my 2, and I see that's nice because I have a 2 on the right hand side. Right? See that 2 there? If I expand out the bottom, I get 1 minus cos theta plus cos theta minus cosine squared theta. And that simplifies for the denominator to be just 1 minus cos squared theta. And now, sometimes it's nice to look back at the other side and think, what do I want in the end? I want something with cosecant. Well, I know cosecant is something over sine. 1 over sine. And maybe you're thinking here, 1 minus cos squared theta. Well, hey, doesn't this Pythagorean identity kind of help us out? Because if I were to move the cosine theta to the right-hand side, look at that. Sine squared theta is 1 minus cosine squared theta, and that's good for me because then I can rewrite this as 2 over sine squared theta, and that's great because that's the same thing as 2 cosecant squared theta, which equals to my right hand side. Done! Alright, one last one here. Cubics. Secants, cotangents. Lots of things look ugly. So you can decide which one to try. I'm going to ask you to try this one out first, okay? But if you really want a hint, I'm thinking what I would do, probably start on the left-hand side because I have 2 terms. It's easier to get 2 terms into one. And because I see tangent theta in both terms, I'm going to factor that out. Okay? That's my first step. Okay? You can decide how you want to approach this. If you want to continue in changing to sine and cosine, you can. I'll let you try this on your own. Okay? Try it. Now, notice when I solved this, I used the Pythagorean identities and the reciprocal identities. You can probably do the same thing if you wanted to change things into sine and cos. You can try that as well, and I believe you'll get the same answer in the end. Okay, I'll leave that as an exercise. Okay, alternative. Okay, so just change everything into sine and cos. That should work as well. Okay, this stuff's not easy. Go ahead and please try some from the book.